Welcome back, guys. This is Mr. Soto's class. We're going to be talking about interval notation in this video. So, I already have a table here. Go ahead and copy this table. Pause it real quick. Copy it down in your notes. And then get back with me right here. I'm going to go ahead and start explaining what this means. Okay? Go for it. Okay. Looking at this table, we're talking about bounded intervals and unbounded intervals. I forgot the S here. Bounded intervals and unbounded intervals. Now, bounded intervals means that you have a restriction around a specific set. So if you're talking about the x value here, x is being restricted by a and b. It's in between a and b. That's what bounded means. If you look at unbounded intervals, you don't have a restriction around both sides. So for example, x is greater than or equal to a. Here, x is bigger than a. A could be any number, but x is going to be getting bigger and bigger and bigger. It doesn't matter how big you get. It's unbounded. Over here, x is bigger than a, but it cannot be bigger than b. It's being restricted by b. That's what bounded means and unbounded. So, looking at this interval notation column, we're going to go ahead and fill it in with the way we write interval notation. X is greater than or equal to a. Because x is equal to a, we're going to go ahead and use a bracket. And in this bracket, we're going to go ahead and write the smallest element in the set. So the smallest number that you can possibly use for x would be the letter a. So the letter a is the smallest. And now the next number after the comma would be the biggest element that you can use in this set. So the biggest that you can get is b, because x can equal to b. So we're going to use b. And since they're equal, we can close it with a bracket. Looking at the next one. X is greater than or equal to a. Again, it's greater than or equal to a being the smallest. B is the biggest, so we go ahead and write b. But notice, b is not equal to x. They don't have the equal sign like it did over here. Therefore, we're going to go ahead and use a parentheses. Next one. A is less than x, less than or equal to b. So, because a is not equal to x, we're going to go ahead and use parentheses. But x is equal to b, b is the biggest, we're going to use a bracket. The last one, as you notice, a is the smallest, b is the biggest. They don't have equal signs, so we're going to use parentheses. A comma b, parentheses. That's it for this part. Now let's look at the unbounded part. X is greater than or equal to a. So here, think about it. X is greater than or equal to a. That means that a has to be the smallest value in the set. Because any value for x that you pick, x has to be bigger. Say for example, a is 5. Can you think of a number that's bigger than 5? 6, 7, 8, 9, 10, 11. It could be any number, 100, 100,000, 100 million, any number. So a has to be the smallest. And when we're never writing interval notation, the smallest number always goes first. Okay? If you look at this interval notation, the smallest number always has to go first. So here we said that a was the smallest, therefore a has to go first. And a is equal to the x, so we go ahead and use a bracket. Now we're going to determine what's the biggest. But because x is unbounded, there's no such thing as the biggest. It's going to keep getting bigger and bigger and bigger as you go. So no matter what number you think of, you can always think of a bigger one. So what we do here is we go ahead and use the infinity symbol as a description of saying that it's going to be unbounded. Okay, the next one, x is greater than a. This is another unbounded. So you know you're going to have an infinity. A is the smallest. So again, we use a. It doesn't have an equal sign. We use parentheses and then infinity. Okay. Now the next one says x is less than or equal to a. That means that x can equal to a, but it cannot pass a. That makes a the biggest number in here. So because a is the biggest number, then a has to go in the back. And a is equal to x, so we use a bracket. But what goes in the front? We have to think of numbers that are smaller than a. So anything that's smaller than a is going to be getting smaller, 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 smaller. And if you keep going all the way to the negative infinity, then it's going to continue getting smaller. There's no specific value. So that's why here we're going to go ahead and write negative infinity, parentheses. Every time you have an infinity symbol, you always use parentheses. Because infinity is not a number. It's a concept. So it's like you can imagine that you keep going forever. You cannot get to infinity. X cannot equal to infinity. So you just keep going and going and going. Okay, this next one says x is less than a. So again, x is less than a. It cannot pass a, it has to be less than. So that means a is the biggest. So a would go on the back, it doesn't equal to x, so we use parentheses. What goes in the front? Again, negative infinity, parentheses. Now this last one. It looks like x is being bounded by a negative infinity and infinity. But however, infinities are not numbers. So technically, x is not being restricted by anything. X can go forever to the left, which is negative infinity. X can go forever to the right, which is positive infinity. So the way we write this interval is negative infinity, infinity. And that's it. This is your table you're going to be using for your notes. And then we can go ahead and move on to these examples. Example number 1, we have negative 8 less than x less than 0. So the way we begin is, okay, the smallest number here is negative 8. So we're going to go ahead and write that in the interval notation. Is negative 8 equal to x? No. Because it's not equal to x, we use parentheses. We put the comma, and then we go ahead and write the biggest number. It's time to go. Yeah, it's time to go. The biggest number is 0, because that's what x is less than 0. And then it's not equal to, so we go ahead and close with the parentheses. And that's it. This is your interval notation. Let's look at example number 2. 4 less than x less than or equal to 10. Okay, we begin by looking at the smallest number in the set, so it's 4. Is 4 equal to x? No, so we use parentheses. The biggest number here is 10. Is 10 equal to x? It is. Since it's equal, we can go ahead and use a bracket. Every time it equals, use brackets. If it's not equal, we use parentheses. Let's look at example number 3. X is less than 11. X is less than 11. So what that means is that it's an unbounded interval. The previous one was bounded. This one's unbounded. So because it's unbounded, we're going to have an infinity somewhere. We got to think about the number 11. Is 11 going to be the biggest number or the smallest number here? Well, x is less than 11. So that means x cannot be higher than 11, which makes 11 the highest number, the biggest number. So 11 is going to go on the right. Is 11 equal to x? No, it's not equal, so we use parentheses. What goes in the front? Well, we got to think of numbers that are smaller than 11. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3. It keeps going forever. So we can go ahead and just label it with negative infinity. Then the last one right here, example number 4. I want you to pause the video right now and try it by yourself. Let's see if you can get the right interval notation. Okay, now we're back. Let's see. X is greater than or equal to 7. So, interval notation, we got to think about the number 7. Is 7 the biggest or the smallest number in here? Well, x is greater than 7, right? So that means that the 7 has to be the smallest. It can equal to 7, so that's fine. So, since 7 is the smallest, the 7 goes first. It's equal, we use a bracket, a comma, and then infinity. Because all the numbers are going to be bigger than 7. You can keep going and going. That's it, guys. I hope you guys understood a little bit better as to what's going on here with interval notation. If you have any more questions, please feel free to come by tomorrow to class or whenever you come back to class and ask me at any time. Also, if you didn't understand the previous video on Set Builder, come by again and try to see if we can talk about it and work with each other so that you can have a better understanding for this. Thank you very much.